Okay, so today we're going to do some chapter 4 review. This is because we got a quiz coming up tomorrow, and I think we probably should focus exactly on what we need to know in order to be successful on that. So here's today's plan. We're going to have some straight to the point review of trigonometry and the unit circle today. This is going to cover radians and arc length. It's going to cover relating coordinates and angles to the unit circle and the Cartesian plane as a whole, reciprocal trig ratios, solving trig equations, and that's about it, right? So the quiz opens on Tuesday, April 7th, but you aren't expected to do the quiz until Wednesday, April 8th. You can do it either day, it's up to you entirely. Anyway, let's get going here. All right, so radians and arc length. Recall that a radian is a way of measuring an angle such that 1 radian, hold on here, 1 radian, is the angle where your radius matches your arc length. So this picture here kind of shows it pretty well. If you notice in this circle, this of course would be 1 radius. But when you have 1 radian as your angle, so 1 radian is your angle, then your arc length is the exact same amount as what your radius, or rather your radian angle was, right? So if, let's say, our radius was just 1, and we had 1 radian as our, angle, then our arc length would also be 1 unit long, right? So arc length, just by the way, the formula on your formula sheet is A equals theta times R. I think it's actually a little different on your formula sheet. I think it's theta equals A over R, but it's easy enough just to rearrange that. You just times by R on both sides and you got it, right? So if you're ever wondering what your arc length is, you can use this formula to find it. Now just keep in mind, if you're gonna use this formula, your angle theta must be in radians for this to work. And on that point, if you want to talk about converting between radians and angles, or rather that should say radians and degrees, if you have radians and you want degrees, take your angle and times by 360 over 2 pi. If you have degrees and you want radians, take your angle and times by 2 pi over 360. Basically, you put the unit that you want to get on the top of the fraction. So if you want degrees, put 360 degrees on the top of it, and on the bottom of the fraction, put the equivalent in radians to get rid of it. And of course, 360 degrees is 2 pi radians. And the same with vice versa. If you have degrees and you want radians, you can go the other way as well. Okay, next slide. Relating coordinates and angles, let's recall the formula for a circle is x squared plus y squared equals r squared. That's very important. I'm not sure if it's on your formula sheet. I can just double check here. I'm not seeing it on here. But regardless, I think it is an important one just to remember. It's x squared plus r squared, or x squared plus y squared equals r squared. Now keep in mind, of course, a unit circle has a radius of 1. So a unit circle's formula would become x squared plus y squared equals 1 squared, and 1 squared, of course, is just 1, right? So here's a couple examples. Is the coordinate root 8 over 3, negative 1 over 3 on the unit circle? Well, if you're ever given a question like this where you're asked to determine if a coordinate is on the unit circle, you can use the equation of a unit circle to confirm that. This, of course, is our x, and this one is our y, so we can just plug these in for our x and our y and see if it equals 1. So if I plug x into that, we're going to get root 8 over 3 squared, plus if I plug y into that, you get negative 1 over 3 squared, and we want to see if that equals 1. Well, first of all, root 8 over 3 squared, to square a fraction, you just square the top and you square the bottom. So squaring the top here is going to give us 8, because square root 8 squared is just 8, divided by 3 squared, which is 9, plus negative 1 squared is 1, over 3 squared is 9, and we want to see if that equals 1. Well, hopefully you can see that 8 over 9 plus 1 over 9 is equal to 9 over 9, and 9 over 9 clearly does equal 1. So yes, that coordinate is on the unit circle. For the next one, for the previous coordinate, what's the measure of the principal angle in radians to the nearest hundredth that connects the origin, and the origin, of course, is 0, 0, to that point? Now, regardless of whether this point here was on the unit circle, you still could do this question, because if it isn't on the unit circle, it's still on the Cartesian plane. The Cartesian plane is just your x and your y grid, right? So again, we're looking for that measure of that angle. Personally, what I like to do is I like to draw a little bit of a picture here. Notice that x is a positive number and y is a negative number. If you think about this on a grid, if x is positive and y is negative, that means x is positive, y is negative, we're going to be down here. So x is your root 8 over 3, and your y is going to be negative 1/3. There we go. So your angle is going to be the angle that connects it to this terminal arm here. Now your true principal angle, of course, goes counterclockwise. It'd be this whole angle all the way around here. But that's kind of tough to find on its own. So instead, that's where we deal with something we call a reference angle, theta r. So theta r, if we found that, we could take it away from this angle right here, the full 360 degrees, or I guess since it's in radians, it's the full 2 pi. And that would tell us what our principal angle would be. To find this reference angle, let's just keep in mind that this is a right triangle. And since it's a right triangle, our right triangle trig still applies. So sine, cos, and tan, they still apply. Notice that this is our opposite side of our angle, and this is our adjacent side. Opposite and adjacent go into tan. So we can say tan theta r equals the opposite side, which is, well, -1/3. Here's where it's going to be a little bit weird, though. Just take my word for this. Ultimately, we're trying to find our reference angle. And remember what I told you before, we never take the inverse sine, cos, or tan of anything that's a negative number. And the reason we don't do that is because it can give us a bit of a confusing answer. So I'm going to ignore this negative for a second. If you don't see why, I'll explain again in just a moment. Opposite is 1/3. Adjacent is √8/3. If we take the inverse tan of this piece right here, that'll spit out our reference angle. And again, if I had left this as -1/√3, it wouldn't have given us a reference angle. It would have given us something else, which may or may not have been the true answer. So I'm going to take the inverse trig of this. Remember, I made it positive on purpose. Take inverse trig of that, and I get theta r equals to the nearest hundredth 0.34. Now, remember, that's just a reference angle. We have to then consider we're in quadrant 4 here, which means we should take our reference angle away from this 2 pi. So my true principal angle here is going to be 2 pi minus, because I'm coming down from it, minus that 0.34. And we'll get this to the nearest hundredth. If you throw that in your calculator, you're going to find that that's equal to 5.94. And remember, that's an angle in radians. Radians don't have any units. You just leave it as 5.94. If you want to say 5.94 radians, that's fine, but by no means do you have to do that. Moving on, relating coordinates and angles again, find the coordinates on the unit circle for a principal angle of 7 pi over 6. Again, this is one of those questions where I just like drawing a picture because it makes it a little bit more clear where we're working. 7 pi over 6, first we should determine where that is. Keep in mind that that is, of course, radians, so I'm going to say that this is pi, because 180 degrees is pi. And 7 pi over 6 is just a little bit more than 1 full pi. 1 full pi would be 6 pi over 6. So 7 pi over 6 is just coming down from here. 7 pi over 6. And hopefully what you can see is that that's coming down from pi by just another reference angle of pi over 6. Now, pi over 6 is actually one of our special triangles. Hopefully you remember that pi over 6 is equal to 30 degrees. And 30 degrees, when in a right triangle, is part of a 30, 60, 90 triangle, and that's, of course, a special triangle. So we could draw that. A special triangle that has a 30-degree angle in it, or in this case, a pi over 6 angle in it, same thing. We should hopefully understand that across from the 30 degrees, or across from the pi over 6, is your side that's 1/2. Adjacent would be √3/2. And your hypotenuse, of course, in these special triangles is always 1, right? So bottom line is we're looking for the coordinates on the unit circle with that principal angle. So if you look back at the triangle that actually shows up on your coordinate grid, it's just this special triangle just flipped around. Across from pi over 6 is your 1/2. So this side here is 1/2. But notice that that side right there represents your y coordinate right here, okay? And because it represents your y coordinate and we're coming down from our x-axis, we can actually say that this is -1/2. Likewise, the side adjacent to this, so this side right here would be that √3/2. But also notice that's our x coordinate. And since that's our x coordinate and we're to the left of our y-axis here, we also have to say that that's -√3/2. So if we wanted to get our actual coordinate for this point, our coordinate, remember you start with x, would be -√3/2. And our y would be -1/2. Next question, reciprocal trig ratios, everybody's favorite thing. Determine the exact value of cosecant 330 degrees. Okay, there's a couple things going on in this one. You could turn this into a reciprocal sine ratio if you're more comfortable with that. What I can do on this one, though, I'll just show you how I would personally do this. I'd say, all right, cosecant of any angle is the reciprocal of sine, and sine is opposite over hypotenuse, so that means cosecant is hypotenuse over opposite. Because again, it's the reciprocal of sine. Sine is opposite over hypotenuse, so I just flip this around, right? Now, the other thing I noticed in this question is 330 degrees is something that's setting up a nice special triangle. Of course, 330 degrees is found just down here, and that leaves a 30-degree reference angle, which means we have an opposite side of 1/2, or rather negative 1/2. I'll just write it as 1/2 for now. Again, we'll come back to that in a second. And an adjacent side of √3/2, and as always, a hypotenuse of 1. That's a 3, by the way. There you go. Anyway, so since cosecant theta is hypotenuse over opposite, given the situation we have here, and this is a 330-degree angle, we can just say that cosecant 330 is the hypotenuse, which is 1, over your opposite side, which is 1/2. Now, 1 over 1/2, 1 divided by 1/2, it's better just to say that as cosecant 330 degrees is 1 divided by 1/2 is 2, right? And the last thing I'm going to do here is actually notice that from the cast rule, which determines whether trig ratios are positive or negative, the only thing down here that should be positive is cosine. Now, cosine has a reciprocal ratio of secant. Cosecant is the reciprocal ratio of sine. Bottom line is, only where sine is positive, so in this quadrant and this quadrant, will cosecant also be positive. But since we're down here in the cos quadrant, we need to say that this is -2. And in this case, because we never actually did any inverse trig, when I listed these side lengths here, I could have called this -1/2. There would have been no problem with that. And as a matter of fact, I would have just had a -1/2 hidden here. 1 divided by -1/2 would have given me -2. But I always just save it for later. It just kind of boils down to personal preference. It's up to you whether you want to do that or not. Again, do whatever is more comfortable. Next one here, determine the exact value of cotangent theta given the terminal arm passes through that point. Okay, so cotangent, kind of like before, we can say that cotangent is the reciprocal of tan. Tan is opposite over adjacent, so we can say that this is adjacent over opposite. If you were to draw that coordinate there, you're going to notice that you have x is -4/3, so let's say it's over here somewhere, and y is 5/2, so it's up here somewhere. So our angle is going to be something like that. Cotangent, like I said, is adjacent over opposite. So if we fill in what this triangle would be, notice my x was -4/3, so I'll write that in there, -4/3. And my opposite side would be my y, so 5/2. This means that cotangent theta is your adjacent side, -4/3, over your opposite side, which is 5/2. But that's a fraction divided by a fraction, and we don't like that too much. So instead, we're going to say that's cotangent theta equals -4/3 times 2/5. Hopefully you remember it's keep, change, flip. So keep the top one, change the divide to a times, and flip the bottom one. This becomes a little more simple. It becomes 4 times, or -4 times 2 is -8, over 3 times 5 is 15. And let's just double check our cast rule to make sure that this thing should actually be negative down here. Well, the cast rule would say CAST. The only thing that should be positive up in this quadrant is sine and, of course, cosecant, because that's a reciprocal of sine. We're dealing with cotangent, which is a reciprocal of tan. So yeah, tan should be negative up here. So in other words, if I wanted to write it out one more time, cotangent theta is -8/15. And that is the exact value, because again, there is no decimals. I didn't round anything there. That is exactly what cotangent theta would be equal to. If this fraction simplified, like if it was -9/15, then please simplify it down. But in this case, I don't have to because it doesn't simplify any further than that. All right, the last things we're going to cover here, I think I got 3 more questions. We'll try to whip through it as quick as we can. Solving trig equations. This is what we did on Friday as well as on Monday. Bottom line on these ones, get your trig ratio all by itself. And then, of course, you can use your inverse trig or whatever other strategies you have at hand to solve for the rest. Also, it's important, watch the domain they give you every single time here. So in this case, we're looking at a theta that's between 0 and 2 pi. That's our hint that we need to deal with radians, okay? Anyway, first things first, let's get all of our trig ratios all by themselves. So I'm going to bring this 3 cos theta over to the other side by subtracting it. 4 cos theta minus 3 cos theta would just be 1 cos theta. So we can say -1 equals cos theta. Now, you might be tempted to do some inverse trig on this. You might say, oh, Mr. Scott, you can't do inverse trig on a negative number, so I got to turn it into +1, use inverse cos on it. You could do that, but you're going to get something that's going to confuse the heck out of you. Inverse cos of 1 is 0. So you might think, oh, where on earth am I? And I wouldn't blame you, because then usually we'd go, okay, if you had your angle, you'd have to just think about what quadrants you're going to be in and then use your reference angle from there, and it just becomes this whole big thing. But there's an easier way of doing this one, just because it's a really strange one. Like if this was cosine theta equals -1/2, that would be absolutely the way you go about it. You just take your inverse trig and you go to town. Or you recognize a special triangle, right? But in this case, because it's equal to -1, and that's a bit of a weird thing for cosine to be equal to, let me actually remind you that cosine theta is your x coordinate. So what this is saying here is your x is -1. If we imagine this being on a unit circle, it becomes pretty clear where x is -1. That's just right over here. So if you think of that being the coordinate that your arm passes through, then in radians between 0 and 2 pi, our angle, theta, must therefore be 1 pi. There is no other angle that's going to fit that here, okay? And by our cast rule, we see that cosine is negative here. Cosine is only usually positive over here, and it's negative over here. Really, -1 is between those two negative quadrants. So we're still good when it comes to the cast rule as well. Bottom line is, though, that would be our angle on this one. Chose that one on purpose because it is a bit of a strange one. Anyway, let's move on to the next. So solve this one, cosecant x minus √2 equals 0 for a domain where x is between 180 and 360. I don't like when questions do this where they call your angle an x. I think that's unnecessarily confusing. I just think it's bad practice. But again, I just took this right out of the textbook, so I'm going to use this one. Cosecant x can be isolated if you move the √2 over by saying cosecant x equals √2. Personally, on this one, to solve this, I don't like solving a reciprocal trig ratio, so I'm going to straight up just turn this to a normal trig ratio right off the bat. Cosecant is a reciprocal of sine, so in other words, we're going to say that sine x equals the reciprocal of √2, which is 1 over √2. Now, I don't like writing it 1 over √2, and neither does your textbook, and neither does Alberta education as a whole, but maybe you would recognize 1 over √2 as being one of your special triangle side lengths. 1 over √2 is more commonly written as √2 over 2. These are the exact same thing. If I just times this by √2 over √2, which is 1, right? √2 divided by √2 would just be 1. You'd get √2 over 2. So those are the exact same thing. And √2 over 2 is actually a side length in your 45, 45, 90 triangle. There we go. So √2 over 2 is both of your side lengths in this. One, of course, is our hypotenuse. So since we know that sine is equal to 1 over √2, or in other words, sine is equal to √2 over 2, that tells us that our angle x, and again, that just pains me calling x an angle, but our angle x is 45 degrees, at least as a reference angle. Again, that just hurts, xr. But reference angle is what that means here, okay? Now, let's think about what quadrants we're working in here. Notice sine is positive. Cosecant was positive as well, but sine would be positive too. And since sine is positive, by the cast rule, we must be in one of these two quadrants up here. But wait a minute. Take a look at your domain. Your domain says that x has to be between 180 degrees and 360. So your domain only includes these two quadrants. But using math, we've determined we have to be up in these two quadrants. So what does that tell us about this question? Well, that actually tells us that there are no solutions. And it isn't that you're limited in this question by the actual equation itself, it's actually that you're limited by the domain. If this was a normal domain, if this had said like from 0 to 360, then you would have been just fine. You would have said, oh, I need a 45-degree reference angle up in quadrant 1 and a 45-degree reference angle in quadrant 2. You would have had your two solutions. But because, oops, hold on, I'm just trying to change to an eraser. There we go, good. Because this was our lower bound of our domain, we kind of were hooped on this one, okay? All right, one more, I swear. Solve this one here. Now, these ones were the really tricky ones that we started, I believe, on Monday. Notice that it kind of takes the format of a quadratic, right? There's a sine squared. So here's what I do. I just substitute out a sign for something else here. So I'll say that sine theta temporarily here, and I'm not going to use x. You know what? I'll use a different letter. How about we call it z? There you go. Cool. I'll just substitute it. You can call it any letter you want. So if I rewrote this, we'd say z squared minus 3z minus 4 equals 0. And this becomes clearly like a normal quadratic where we can say, oh, we have a sum of -3 and a product of -4. Well, what two numbers add to be -3 but would multiply to be -4? Well, if you think about it for a second, you'll see, oh, it's got to be actually -4 and +1. So since it's -4 and +1, we can just jump straight to a factored form because this is just a 1z squared thing here. So we can say z minus 4 times z plus 1 equals 0. Now let's switch our sign back here. So we can say sine theta minus 4 times sine theta plus 1 equals 0. There we go. Now we have something we can solve a little better. Now, just in case you're wondering, I like substituting out sine for z here because I think it just makes it a little bit more clear to an observer what we're actually doing, because having sine in here and using like quadratic factoring on that is kind of bizarre. But you don't have to do this. These steps here, optional. If you can still see that you can just pretend that that was an x squared or a z squared or whatever and factor it normally, go for it. Don't feel like you're stuck in having to do this, right? Anyway, long story short, we can say in this factor, because for this to be equal to 0, either this piece has to be 0 or this piece to be 0. For this factor, we'd have to say that sine theta equals 4. And for this one, we'd have to say that sine theta equals -1. Now, this right off the bat, I don't even have to do any calculations. I can tell you that this one right here is garbage. And that's because I know that sine only has a range between -1 and +1. Sine of an angle can't be anything outside that range, -1 to +1. And if you don't believe me, you could take inverse sine in your calculator of 4 to try to find this angle here, and you're just going to get an error message, regardless of whether you're in degrees or radians. So this one, therefore, means there's no answer. So we can just ignore it. There's no way that this is ever going to even happen. So no, we just ignore it, right? As for this one, it's kind of a similar problem to the one we saw a couple slides ago where I said cosine theta equals -1. You could use inverse sine on this and see what it gets you. But personally, when I have it actually equal to -1, I just like realizing that I see sine theta is actually your y coordinate, right? And since sine is your y coordinate, do you think where y is -1? Well, that's an angle of 270 degrees, right? That's the only way that that's ever going to happen, especially if it's on, of course, a unit circle that's not quite as squiggly on the sides as I drew. But you get the idea. If it's on a unit circle and you have your sine is -1, that means your y is -1, and that only occurs in one place. You know, with exception of other things like 1/2, which actually shows up twice, and that's why we had to consider it twice. But -1 or -1/2, sorry, but -1 only occurs one time. Anyway, long story short, I'm rambling here. From this one, we can tell that our theta equals 270 degrees. And that is the only answer for this factor. And this factor had no answers at all. And because we're dealing with a domain of between 0 and 360 degrees, this right here, theta equals 270, is our only solution. We don't have any other solutions outside of that one. Okay, that went for longer than I was hoping, but still, I think you should get a little bit of practice in here. Page 215, questions 3, 7, 9, 13, 14, 20. If you see a couple questions in there and you're like, okay, I know how to do them, then skip them, right? Try some of these questions though. These questions I've handpicked because they're very similar to the ones you can expect on that quiz tomorrow. And again, as always, don't be afraid to ask for help from me directly when needed. You can send me an email, you can send me a reminder. If you want to have a one-on-one Zoom meeting for me to actually like go through something with you, we can do that. Just let me know, give me a little bit of notice so I can make sure I'm getting ready for that, right? Now the quiz will cover what we reviewed today. So all of chapter 4, if you want to use your textbook on that. It's going to consist of 10 multiple choice questions worth 10 marks and 2 written response questions worth 5 marks. You need to be prepared to take either a photo or scan your written response answers and upload them to Google Classroom. That's how that's going to work. For those of you in physics, it should be pretty familiar because we did the same thing on our quiz in that course too. Now the quiz must be completed before Wednesday night. That is your deadline on that. Please get it done. If you have any questions, again, you know where to contact me. Best of luck, guys.